Thermal and moisture protection are vital aspects in designing and maintaining an environmentally responsible structure. It includes the materials used to seal the outside of the building against moisture, thermal, and air penetration, plus the associated insulation and accessories.
Today, we will going to talk about the thermal and moisture protection. Waterproofing and damp proofing. In waterproofing of concrete, a mortar or concrete is considered impermeable when it does not permit passage or flow of water through its pores or voids. The absorption of a mortar or concrete is the property of drawing in or engrossing water into pores or voids by capillary action. If the pores or voids between particles are sufficiently large and connected from surface to surface of the wall, the concrete will be permeable to water. If the pores or voids are very minute but connect with one another, theoretically they may act as capillary tubes. But capillary tubes will tend to hold the water and prevent the passage of water. So there are various methods of waterproofing concrete. The first is impermeability through a dense concrete. Second is the waterproofing coating and washes. Third is the integral waterproofing compounds. Fourth is the membrane waterproofing.
The next one we have performed roofing. There are four types of roofing, namely sheet metal roofing, plastic roofing, tile roofing, and shingles. In sheet metal roofing, we have two types, the galvanized iron roofing and aluminum roofing. Both types are produced with or without corrugations and rib sections. They are made susceptible to weather-related conditions to provide shed. The difference between them is that aluminum is lighter and is usually preferred for its anti-corrosive and thermal conductivity properties, whereas galvanized is obtained by a hot dipping process in which carbon is dipped into zinc, and they are usually expensive. Next, we have plastic roofing. The corrugated or ribbed roofing and sheet roofing are the two types of plastic roofing. The corrugated roofing is ideally used in sites of high salinity levels. These are corrugated sheets that are manufactured in same widths and lengths as metal sheet roofing. On the other hand, the sheet roofing uses polycarbonate sheets which are ideally used in greenhouses, patios, other sheds, and skylights. Moving on is the tile roofing. Obviously, this type of roofing uses kinds of tiles. We have either clay tiles or concrete tiles for roofing. The last one is shingles. We have wood shingles and tar or asphalt shingles. Wood shingles usually lasts up to 30 years, but it requires yearly upkeep. On the other hand, higher quality of asphalt shingles lasts up to 50 years. However, typically they only last for about 20 years. Next are the joint sealants. These joint sealants minimize both infiltration of surface water and incompressible material into the joint system. These are used to fill and protect joints between two substrates, sealing gaps and openings. We have two types, the bituminous cement and silicone sealant. Bituminous cement is a black substance available in solid, semi-solid, or liquid states at normal temperatures. It is composed of mixed indeterminate hydrocarbons, appreciably soluble only in carbon disulfide or other volatile liquid hydrocarbon. Bituminous cement is used for sealing built-up roofing and joints and cracks of concrete pavements. Proceeding to silicon sealants, they are commonly used to seal window frames or windows to frames, for they provide water-resistant seal which maintains a strong hold against bad weather conditions or harsh weather conditions. They are also often used for automobiles, appliances, sealing cables, and sensors.
So metals is any of a class of elementary substances as gold, silver, or copper, all of which are crystalline when solid and many of which are characterized by opacity, ductility, conductivity, and a unique luster when freshly fractured. So ferrous metal. A metal containing iron is the principal element. A non-ferrous metal, any metal containing little or no iron at all. Ferrous metal. First, iron, a malleable, ductile, magnetic, silver-white metallic element from which pig iron and steel are made. 1.1. Pig iron. Crude iron that is drawn from blast furnace and cast into pigs in preparation for conversion into a cast iron, wrought iron, or steel. 1.2. Cast iron. A hard, brittle, non-malleable iron-based alloy containing 2.0% to 4.5% carbon and 0.5% to 3% silicon, cast in a sand mold and machined to make building products. Malleable cast iron. Cast iron that been annealed by transforming the carbon content into graphite and removing it completely. Wrought iron. A tough, malleable, relative soft iron that is readily forged and welded, having a fibrous structure containing approximately 0.2% carbon and a small amount of uniformly distributed slag. Steel. Any various iron-based alloy having a carbon content less than that of cast iron and more than that of wrought iron. Carbon steel. An ordinary unalloyed steel in which the residual elements as carbon, manganese, phosphorus, sulfur, and silicon are controlled. Kinds of steel. First, mild steel. A low carbon steel containing from 0.15% to 0.25% carbon, also called as soft steel. Second, medium steel. A carbon steel containing from 0.25% to 0.45% carbon. Third, hard steel. A high carbon steel containing from 0.45% to 0.85% carbon. Fourth, spring steel. A high carbon steel containing from 0.85% to 1.80% carbon. Next kind of steel, alloy steel. Carbon steel to which various elements as chromium, cobalt, copper, manganese, molybdenum, nickel, tungsten, or vanadium have been added in sufficient amount to obtain particular physical or chemical properties. Kind of alloy steel. First, stainless steel. An alloy containing a minimum of 12% chromium, sometimes with nickels, manganese, or molybdenum as additional alloying element. Second, high-strength low alloy steel. Any of the group of low-carbon steel containing less than 2% alloy in a chemical composition specifically developed for increased strength, ductility, and resistance to corrosion. Third, weathering steel. A high-strength low alloy steel that forms an oxide when exposed to rain or moisture in the atmosphere, which adheres firmly to the base of the metal. Next kind of steel, zinc, a ductile crystalline bluish-white metallic element used for galvanizing iron and steel and in making other alloys. Symbol is Z and N. Chromium, a lustrous, hard, brittle metallic used in alloy steels for hardness and corrosion resistance, and for electroplating other metals. And lastly, tin, a lustrous, low-melting bluish-white metallic element that is malleable and ductile at ordinary temperatures and used in plating and making alloys and self-solders. Symbol SN.
Structural steel selections. W shape. A hot-rolled structural steel section having an H-shape with wide parallel flanges, designated by the prefix W followed by the size and weight of the member, also called wide flange. So basically, a wide flange steel beam is a structural product made of rolled steel, known for its sturdiness and ability to hold up large and heavy buildings. The wide flange beam is preferable in construction projects. The H design allows even distribution of weight without affecting the structural properties. M shape. A hot rolled structural steel shape similar but not classified as W shape, designated by the prefix M followed by the size and weight of the member. So, a miscellaneous beam or M-beam provide an exceptional low weight per foot hot-rolled solution, primarily used in the frames of manufactured homes and recreational vehicles. This product is also utilized in purling applications and for steel dunnage. HP shape, a hot-rolled structural steel selection similar to W shape but having flanges and web of equal thickness and typically used as a load-bearing pile. Designated by the prefix HP followed by the size and weight of the member. An HP shape is almost identical to the W shape. The only difference is the flange thickness and web thickness of the bearing pile are equal, whereas W shape has different web and flange thickness. S shape, a hot rolled structural steel selection having an I shape with slope inner flange surfaces, designated by the prefix S followed by the size and weight of the member, also called American Standard Beam. So S-shape is distinguished by its cross-section being shaped like the letter I. S-shapes are used less frequently than W-shapes, since the S-shapes possesses less strength and less adaptable than W-shapes. There are two types of method upon creating this structural steel. First is cold formed or cold rolled, descriptive of a metal that has been formed by rolling at room temperature, usually to obtain desired form or improved surface or higher tensile strength. Second is hot rolled. It is descriptive of a metal obtained by rolling the metal while still hot, results in dark, oxidized, relatively rough surface.
Structural steel shapes. 1. American Standard Channel. It is a hot-rolled structural steel section having a rectangular C shape with slope inner flange surfaces. It is designated by the prefix C followed by the size and weight of the member. Next is miscellaneous channel. It is a hot-rolled steel section similar to a C shape but designated by the prefix MC followed by the size and weight of the member. And now, let us proceed to angles. Angle is a hot-rolled structural steel section having an L shape designated by the prefix L followed by the length of each leg and their thickness. It is also called iron angle. There are three kinds of angle. The first one is equal angle. It is an angle having legs of equal length. The next is an equal leg angle. It is an angle having legs of unequal length. The last one is a double angle. It is a structural member consisting of pair of angles joined back to back. Number 3. Structural T. A structural T is a structural steel section cut from a W, S, or M shape and having a T shape. It is designated by the prefix WT, ST, or MT, depending the section from which it is cut, followed by the size and weight of the member. A rolled metal bar having a T-shaped cross-section is also called a T-bar. Number 4. Z. It is a rolled metal bar having a Z-shaped cross-section with internal right angles. It is also called a Z-bar. Number 5. Bar. It is a long solid piece of metal, especially one having a square, rectangular, or other simple cross-sectional shape. Number 6. Structural tubing. It is a hollow structural steel shape of square, rectangular, or circular cross section. It is designated by the prefix Ts followed by the side dimensions or diameter and the wall thickness. Reinforcing bar. It is a steel bar for reinforcing concrete, usually specified with a number equivalent to its diameter in eighth of an inch. It is also called a rebar. Deform bar, a reinforcing bar, a hot rolled with surface deformations to develop a greater band with concrete.
Welded wire fabric, a grid of longitudinal and transverse steel wires or bars welded together at all points of intersection, usually specified by the size of the grid in inches and the wire gauge, also called welded wire mesh. Woven wire fabric, a mesh of cold-drawn steel wires mechanically twisted together to form hexagonally shaped openings. Non-ferrous metals. Aluminum, a ductile, malleable, silver-white metallic element that is used in forming many hard, light alloys often anodized for better corrosion resistance, color, and surface hardness. Copper, a ductile, malleable, reddish-brown metallic element that is an excellent conductor of heat and electricity, and is widely used for electrical wiring, water piping, and in the manufacture of alloys, as bronze and brass. Lead, a heavy, soft, malleable, bluish-gray metallic element used in solder and radiation shielding. Brass, any of various alloy consisting essentially of copper and zinc, used for windows, railing, trim, and finished hardware. Bronze, traditionally any of various alloys consisting essentially of copper and tin, and sometimes traces of other metals. Antimony, a brittle, crystalline silver-white metallic element used chiefly in alloys. Cadmium, a white, ductile metallic element resembling tin, used in plating and making certain alloys. Carbide, a very hard material of carbon and one or more heavy metals, as tungsten carbide, used for cutting edges and dies. Magnesium, a light, ductile, silver-white metallic element, used in lightweight alloys. Manganese, a hard, brittle metallic element used chiefly as an alloying element to increase the hardness and toughness of steel. Nickel, a hard, silvery white malleable and ductile metallic element used in steel and cast iron alloys, and in electric plating metals which requires corrosion resistance. Silicon, a non-metallic element having amorphous or crystalline forms, used especially in electronic devices and to strengthen low-alloy steels. Tungsten, a heavy, brittle, gray-white metallic element having a high melting point and used in electrical elements and for hardening alloys. Vanadium, a malleable, ductile, grayish metallic element used in forming alloys.